All right, so like we said, the basics of transformation, it has all these letters here. It's got the function out front. That's just telling you what the function is. Sometimes it will say f of something because it's a generic function and it doesn't matter what it is. Sometimes it will have one of the parent functions, which we're going to see a couple different examples of this. Anything outside, the a value out front and the k value in the back affects the y values, where anything inside, the b and the h, affects the x values. You remember from quadratics, anything on the inside, it was always the opposite of what it looked like. So if it was a plus, it was actually left, and it was a minus, it was actually right. It works the same way with the b value. So we're going to see that here in just a minute. The outside stuff, the a and the k, is exactly what it looks like. Okay? So make yourself a list of things. Here is what a does. A is a vertical stretch or shrink. Okay, it's a stretch if that a value is larger than 1. It is a shrink if it is between 0 and 1, like a fraction like 1/2, 2/3, 1/4, something like that. A also does one more thing. If it is negative, it is a reflection over the x-axis. Now, something I want to point out there. We said anything outside affects the y values. So this is something you're going to do to the y values, but it results in a reflection over the x-axis. Okay? H and K are very simple, so it's the A and the B that tends to throw us for a loop, so we're going to take a minute on those. B, if A out front is a vertical stretch or shrink, B is a horizontal stretch or shrink. Remember how we said B is going to be the exact opposite of what it looks like? So that means for it to be a stretch, it's going to be a B value between 0 and 1. For a shrink, it's going to be a B value larger than 1 because you're going to do the opposite of what it says. If it says the B is 2, you're actually going to divide by 2 rather than multiply, stuff like that. Okay? H and K are very simple. H is your left-right shift. K is your up-down shift. Now remember, H is also going to be the opposite of what it looks like. So for it to look like it's going left, what are you going to see in there? A plus. For it to go right, it's going to look like minus. Where K is up is plus and down is minus. All right, I'm going to give you a minute just to write this stuff down.
I go wash off my hands.
Yes.
They don't come out.
All right, so these are generic functions. These aren't anything in particular. So that's what the F is there. It's telling you where's the inside and where's the outside, right? So on something like number 1, it's just showing me here that this is inside, which means what kind of transformation is this?
Left or right?
Left or right, because it's a minus, it's what? Right 1. And then this is what?
Up 2.
Up 2, right?
So
how is this?
different than...
We're going to talk about it. I'm not going to the hard questions right away.
What do we have to worry about the F? Did it come out, Max?
It's going right 1 because inside everything is the opposite. If it says minus, it's actually right. If it says plus, it's actually left. Yep. All right. So the same type of thing for question 2. If this is in here, what does this mean? Left what?
Left 7, up 8.
Up 8. All right, now let's start talking about some of the vertical stuff and stretches and shrinks. Question 3. This 2 is outside, which means is it a vertical or a horizontal?
That's for the slope, right?
Okay, it's like the slope. We call this a vertical stretch or shrink. Stretch because it's larger than 1 of 2. Inside, just like before, would be right 1. It is. Yep. Okay. One more like this, and then I'm going to make up one that has more stuff in it with the inside. We'll talk about it in just a second. All right, 6 actually has 3 transformations in it. Okay? Because this right here is 2. Okay, the negative has nothing to do with the vertical stretch or shrink. The negative, what is the negative specifically?
Down 3 over 4.
It's a reflection across the x-axis. Okay, the 3/4 is a vertical what? Shrink. Nope.
Oh, I hate physics.
And what is the +6? Left 6.
Oh, left 6.
All right. There isn't one in this little set of examples with horizontal stuff, but I do want to go over one. So I'm going to scratch out 7 and write you a new one here. Okay?
7 is pretty easy, right?
I know. I'm going to make an example here with lots of things going on in it.
If the number out front is negative.
All right, so let's talk about 7 because this is the first time we've seen one on the inside. Okay, one on the inside changes a little bit of stuff. Okay, so the 2 outside, we've already talked about something like that. That's a vertical what?
Stretch.
I can't spell. Vertical stretch. Okay.
Would be horizontal stretch?
This one, the 1/2 is going to be a horizontal what? Stretch. Okay? And remember we said on the inside it's always the opposite. So it looks like it's multiplying by 1/2. When I actually do this on a graph, which we're going to head to next, you're actually not going to multiply by 1/2. You're actually going to multiply by the reciprocal. 2.
So 2.
That negative inside, though, is something completely different. What is that negative inside? It's a reflection over what?
X-axis.
Y-axis. If it's inside, it affects the x's, but it's over the y-axis. If it's outside, it affects the y's, but it's over the x-axis. And then, of course, you know the left 7 and down 3. Okay? I'm going to tell you right now that this is going to be extremely frustrating for you if you don't try to focus on some of this. Because once we get to the graph, then you're actually going to have to do something with this. Yes? Because when you multiply anything on the inside, which is all of this, when you multiply the x values by a negative number, it flips it over the y-axis because it changes the side of the x's.
Over the y-axis because it's negative?
Yes.
So if it was a positive 1/2, it'd just be a...
It would just be a horizontal stretch.
So,
Mhm.
like usually on a regular graph,
Mhm.
the number's higher.
Mhm.
Goes like that.
Mhm. Yep.
It's like less than 1. It goes
Mhm.
like that.
But those were all for quadratics vertical. We did not do anything horizontal on the inside. So that's why it was always a stretch. If it's outside, it stays like that. If it's inside, it messes with it. Okay?
Like outside of X, Y.
Outside affects y's, inside affects x's. Yep.
But it flips X.
Yes.
Then
Yeah.
flips Y.
Yep.
Affects X.
Mm-hmm. Yes. All right. I'm going to pause just for a moment. Can we identify these at this point a little bit? No? Why? What part of it's still confusing? Yes? All right, so we're going to practice doing a couple graphs here. Some of these are super easy, but from what I've heard last year, y'all did a lot of graphs with left and right and reflections, but not the vertical and horizontal stretches. So that's kind of like what we're adding to that this time. So what we're going to see here is a couple easy examples, and then we're going to write a couple of our own that will be a little bit more difficult. So for something like 1, notice this is not a generic function anymore. This is where the parent functions come into play. What is the parent function of 1?
1.
It's an absolute value function. So it's that V shape that starts normally at 0, 0. But this is a transformation since it is inside. Which way is this 4 moving in? Left 4.
Left 4.
All right. So we take our graph, we move it left 4 for its starting location, and we draw an absolute value function. Nothing super difficult if it's just left, right, up, down shifts, right? Those are not super anything weird.
What if the 5? What if there's like a?
We're going to get there in just a second. Just hold.
You have to draw the arrow.
Yeah, because it keeps going.
Just like the justification process.
All right, 3. I'm going to skip 2. 3 has 2 things. It goes which 2 ways? Right 3, up 2. So that means my starting location for this is right 3, up 2. Draw your absolute value.
That's straight cash.
All right? Now, I'm going to skip down to question 5. Here, when we start throwing the vertical and horizontal shifts in, or stretches, this is where it gets a little bit confusing. And I will say right up front that I'm going to show you a method that I have taught for several years of doing these with the vertical and horizontal stretches and shrinks. I personally am not a very visual person when it comes to doing math. I don't like to do graphs. Geometry is kind of more visual. I'm not that type of person. I'm more the analytical. I like to do the numbers of this rather than graphing 15 different things. If you are a visual person and you can do 4 different transformations on something on a graph, you are more than welcome to do that. I'm just going to show you a way to not do that because I find that very confusing. 5 is kind of an easy example of one that has a vertical stretch in it. Right? This has 3 transformations in question 5. This 4 goes up 4, right? And what did we say the 1/2 is out front? There's 2 parts to that. It's a vertical shrink, and it is what? Okay. Now, if I'm going to do this, I have to still use order of operations. Okay? Order of operations says anything that is multiplied has to be done before anything that's added and subtracted, which means I have to take care of that negative 1/2 first. So the normal absolute value function starts at 0, 0 and has a slope of up 1 over 1 going this way, right? If that negative 1/2 is out front, it takes that, it flips it down, and it changes the slope to negative 1/2. So my first transformation that I would do, and this is kind of the visual way of doing it, which I choose not to do. So I'm just kind of showing you the long way first, and then I'll show you the other way. So I would first do my transformation where I do the vertical shrink and the reflection in one step. After that is where you have to deal with the up 4. So I had the parent function. A vertical shrink changes the slope to negative 1/2 instead of positive 1.
No, because you see the negative 1/2 in front of it, it's like that's the slope.
Mm-hmm.
With the other problems. So what a vertical shrink does is you just flip it and then you just go down 1 over 2. That's all.
Yeah.
That's it. But you also can't remember about the up 4.
All right. So then you have a third graph here where you take that entire orange function and move it up 4. All right. Now, here's where you're just going to have to kind of stick with me for a moment. Okay, so so within some of these functions, like the absolute value one is one in particular where a vertical stretch or shrink looks a lot like a horizontal stretch or shrink. You could look at that graph and tell me that's a horizontal stretch. You can also make it a vertical shrink. This one, it only works that way because the change in the x and the change in the y for every point is the same. It's up 1 over 1 for every point. So it only works that way for that. Now, like I said, I'm not a visual person. I don't like to draw 3 graphs to get my final answer. Okay? Here's where I'm going to need you to just stick with me for a moment and just understand there is a method to this madness that is happening in my head. Okay? It'll make sense after a couple examples. I don't like to do 3 graphs. Here's what I like to do. I prefer to stick with numbers. On the original parent function, absolute value, where did you tell me my absolute value function starts in the middle? 0, 0. I really only want 3 points in my little table that I'm about to do here. So what's 1 point to the left that I can do? Negative 1, what's the absolute value of negative 1? 1. And positive 1, what's the absolute value of positive 1? 1. All right. We said anything on the outside of the function affects the y's, right? So in my table, am I going to change any part of my x values? No, because everything out front and at the back affects the y's. So I can take this table of 3 points and I can multiply and add and subtract to this table to get my final points without graphing 3 times. You can shake your head at me right now. I'm going to throw an example at you in a minute where you are not going to want to graph it. I promise you. I promise you. And this will be stuff that is on your quizzes and tests. So just stick with me. I promise there's a reason for this. I would still stick with order of operations on this, okay, which means I have to do my multiplication and division first. I can take care of that reflection and vertical shrink at the same time. I can multiply my y values by negative 1/2. Okay? That negative 1/2 is a multiplication by your y values because it's outside. Then what is that plus 4? It's literally just adding 4 to the y's, right? So I take my new y values that I just got, and I add 4 to each of them.
3 3/4. Oh.
Okay? Those are my new points. I graph those 3 points,
Wow.
and that's in the exact same spot. I prefer this. Okay, and I'm going to show you an example. If you are a visual person, you're all of a sudden going to become a table person when I give you another example.
I'm
Yeah.
just not sure where you get the.
You're doing stuff on the outside because
Anything on the outside affects the y's. Anything on the inside affects the x's. Technically here, is there anything on the inside? No.
that's the only
So that's why nothing affected the x's.
I'm just
Yes.
not sure where you got the number.
So I'd start with the quadratic parent function. I'd have to take that quadratic parent function, do both a vertical stretch and a horizontal stretch and a reflection, and then move it left 4 and down 1. I don't like to do that on a graph, again. So I would like to just kind of show my work in a table here. So let's just talk about a quadratic parent function. Think about that U shape. That one right there. Where does it start in the middle?
0 0 origin.
0, 0,
Negative 1 and
negative 1,
negative 1
1.
and 1 1.
Okay, there we go. So those are 3 points on the parent function. Could you use other points? Yes, but why make them difficult for yourself? Okay? All right, now, let's go back through this. That stuff is inside. Do we see how that stuff is inside? Yes, because it's all inside the parentheses and the squares. That means everything inside my box affects my what? X. And it's also all inside the opposite of what it looks like. So for right now, we're just going to work on the outside. Remember, we multiply and divide first. So the first thing I'm going to do is look at that 2 out front. That is a vertical stretch of 2, which means I'm going to take the y's in my table and multiply by what? 2. Step 1. This is stretching the y's. It's taking all my y values and stretching them up too. Inside, think carefully before you answer about this. That negative 1/3 is 2 things. It is a reflection over the y-axis because of the negative. And remember we said anything inside is the opposite. It looks like it's multiplying by 1/3. What should I actually multiply my x's by? 3. Okay? X's are always the opposite.
Why would you not just know it's plus 1?
Well, you could. Yeah, if you want to finish the y's right now, you can. I always say do all your multiplication and division before you do the addition and subtraction, but as long as you do the multiplication to the y's and then the addition, yeah, you can finish the y's here.
Wait, doesn't that go against GymDOS?
No, because you're only doing it to the y. You've already done the multiplication for the y. You can then do the subtraction to it. All right, let's go back to the x's then. If you want to do the subtraction from the y's there, you can. It doesn't matter as long as you do the multiplication first. Second step then for the x's. I'm going to take my x's and multiply them by -3 to take care of both the reflection and the stretch. Then the only other thing that needs to be done to the x's is what? Subtract 4 because it's the opposite.
What about, can you go over the 3 thing again?
Anything inside is the opposite. So when it looks like it's multiplying by negative 1/3, it's actually multiplying by -3. Just like it looks like plus 4, so we minus 4.
But isn't it like the opposite? It would be called.
No, that's a left 4. Yeah?
Is that a reflection over the x-axis or y-axis?
That's a reflection over the y-axis. It affects the x values, but it's over the y-axis. So once I have those, I then have 3 ordered pairs at the end. -1, 1.
Oh, I see.
Okay. I have -4, -1. And I have -7, 1. We all know what a quadratic looks like. Okay, it has been reflected over the y-axis, vertical stretch of 2, horizontal stretch of 1 or of 3, right? I know. But you can kind of see why I do the table stuff for that rather than try to do it visually. And I'm just telling you up front, you are going to have to do these transformations to trig functions, sine, cosine functions. That's the answer.
Which axis was it on?
All right.
Which axis do you?
All right, so to review, anything inside here affects the x's. Anything outside here affects the y's. This is a parent function that is a what? Cubic. So first, let's find ourselves some points for the cubic parent function. You can do 1, 1, 0, 0, negative 1, negative 1. Those are all on the cubic S-shaped parent function. I would, because on the cubic, it goes down to the left. Oh my gosh. All right. Any multiplication we do first, which means I'm going to do 2 multiplications here. The 3 out front affects the what?
Y.
The y's. So I multiply the y's by 3. Technically speaking, it looks like you're multiplying by negative 1 on the inside. Quick question, is multiplying by negative 1 any different than dividing by negative 1? No. It just flips the signs of the x's no matter what you do. So I would multiply my x's by negative 1, or switch the signs, or divide by negative 1, however you feel comfortable. There are 2 more things to be done to each of these. That is, the reciprocal of negative 1 is also negative 1. So it doesn't change what you do.
So the y is u and I'm not y.
Because the reciprocal of
Negative 1.
multiplying by negative 1 is divided.
It's the you guys are thinking opposite signs of stuff. You want to think opposite operation. It looks like you're multiplying by negative 1, so think the opposite of that is dividing by negative 1.
So like for the one, when it was negative 1/3, then how come it's
Because the opposite of multiplying by 1/3 is dividing by 1/3, which is the same as multiplying by the reciprocal. You can think multiplying by the reciprocal. The reciprocal of negative 1 is still negative 1. Negative 1 over 1 is still negative 1 over 1 when you flip it. Yeah? Okay. Then to the x's, I would go through and subtract 1. And do what to the y's finally? Minus 4. Because the y's, you do exactly what it says. So I have 0, negative 1, negative 1, negative 4, and negative 2. Did I do something? What did I do?
Yeah, I feel like.
That should be...
What, shouldn't it be negative at the top?
Yes, thank you. I did do something there. This should be a negative 3, which makes that a negative 7. Thank you. It was not working out right. So that's here. Remember, your cubic is an S shape. So it's a very stretched one in this case. But that's what it ends up looking like. Okay. Homework has been edited because of my changes on here. So if you would flip over to page 122. Most of your homework is extremely easy. Okay, there are some of these. Okay, there's quite a few problems, but a lot of them are easy. So this is page 122. We are going to do part 1, not part 2 on page 123. So cross out the graphs on 123. But then we are going to do part 3 and part 4. I realize that's a lot of questions there, and I have some extra graphs then I want to do. But look at this for a minute and just tell me this should be easy for you. Okay? This one you're just identifying it's a absolute value function moved up 3 and writing the equation like this. So this should take you approximately 5 minutes to get through sections 1, 3, and 4. I do want you to try some of the graph stuff, okay, with making the tables, okay, or however you want to do it visually. So we are doing 122 through 124, parts 1, 3, and 4, and then this graph sheet, which I'm counting too many papers. There we go.